In the last video, we were able to get the 8.1 liter Vortec and Allison transmission into the actual truck itself, but unfortunately, we weren't able to get the transmission bolted in. It clearly was not meant to be in here, but that's okay. What we're gonna go ahead and do is finish pushing this thing out of the carport, and we're gonna go ahead and design and manufacture our own transmission cross member for the Allison 1000. That being said, it rolls pretty easy. Sort of. Oh. There we go. Yeah. There we go. It's going to be a pretty quick and painless endeavor, I say now. All right, guys, we're underneath, and as you can see, we have the transmission sitting right there and a computer sitting right there. I actually had to steal the wife's laptop because my laptop for tuning computers can't do scanning. It will literally freak out. So I use my desktop for the actual designing process, and for scanning, shout out to the wife for letting me steal her laptop. Anywho, here's an old trick that I learned back, I don't know, 20 years ago from an old timer. Take a ratchet strap to support your transmission so you can move the vehicle around and everything. But yeah, if you didn't know that, that's how I do it. Now that we're going to be taking stuff off and everything, you just, you know, secure the transmission. Anyways, so the first thing we're going to go ahead and do, now I had a lot of troubles with this. This is the Creality Raptor, just the standard Raptor, not a Pro, nothing like that. And this does both laser as well as LiDAR or infrared scanning. Now, for smaller projects where you're trying to get, like, reproduce a part or something like that, the blue laser is amazing. The accuracy, so good. Now, again, this is not an endorsement per se. I bought this with my own money, and I had an absolute nightmare to get the thing working. It took 2 days, and I had to go to my mom's house and use an Android phone to do an update on it because out of the box it doesn't work. So hopefully they fixed it. I mean, it was a problem that was known for about 3 months. So if you're buying a 3D scanner, this is awesome if you can get it working, but be prepared for a headache. They do make other ones, and there's other brands. Now, there was no mention about it on their website, and it was the forums that were able to get the problem to solve itself. It was heads up. Anyways, we're going to go ahead and we're going to create a new project right here. We're going to call it trans. There we go. We're going to move over to this thing. Oh, and we're going to use the infrared mode. We're going to do medium, no markers, geometry, and disable the flat base. The disable the flat base is designed so if you're scanning something, if it's on the floor, it won't read the floor. That being said, don't enable it. It is buggy as hell. It doesn't work, and it will make it so trying to scan anything is an absolute unmitigated nightmare. So make sure it's disabled, and we'll go ahead and start the scan process. It'll initialize, take a few seconds, and you're going to be able to take the scanner. Make sure you use the little hand lanyard thing, because if you drop this thing and it hits the ground, it'll mess with the calibration. And you can see we put that towards the transmission. This is actually up, so you put it towards the transmission, and you can start seeing that, you know, the green is good. Green means it has a nice visualization on range and everything, and you'll start being able to scan it. Now, to start scanning it, you press this little button once you're happy with what the color is. And I'm using my phone to actually see that, and now it will start to scan. This is inverted. It's weird, and it does a really good job. I've been using it for doing the super stuff. And let me turn it around so you can see. All right, this is a little bit difficult, but you can see what I've already scanned. And if we look over here, pull far enough back, you can see the color change on where the little play button is. You can see once it gets in a nice position, it will change the color. If you're too far away, it'll turn, you know, all different colors, right? You can zoom in and stuff and increase the how much information based off of its exposure and stuff like that right through here. But you can zoom in. So like if you're watching over here, it'll physically zoom in like you're zooming in a camera. So if you want to see what you're doing and a little bit closer, but you know, this has to be further away, you can do that. And so you're going to go ahead and just start scanning the whole thing. And you want to get as much detail as you possibly can, change the angles, because you're literally creating a 3D representation of the entire thing. So, and it will yell at you a bunch. You get the general idea. I'm going to take a few minutes. It's probably going to take about an hour to scan everything, just because, you know, sometimes it's a bit finicky. And once I'm done scanning it, we'll go into the house, we'll upload it onto my desktop computer, and then we'll be able to render it out and use it in a CAD program. Once we have the CAD program opened, we'll be able to design the actual geometry. And from there, you'd be able to run it through like a plasma table or something like that. We are not that fancy. We're going to go ahead and get the grinder out and stuff like that and just do it the old-fashioned way. So forgive me for not having a capturing software, and also then how can you see my hands when I'm doing stuff? But this is the environment that you're going to be working in. You can kind of scoot it around by grabbing. You can use your shift, and you can manipulate the screen and really get a good idea. This right here is going to be our frame rails right through there. So your C channel is like that, but we just needed to have those surfaces so we knew where we're going to be mounting it. And there's our transmission mount right there. We needed the other stuff so we knew what we were going to hit and what we're not going to hit. And then we can start playing with different ideas as we go. First thing we're going to want to do is draw the tube. So this is where we're going to be able to mount our brackets to, and this will give us an idea how close we can get to the transmission mount. If you want to see how that looks, we can actually open up that drawing here, and we can go ahead and hide the mesh from that and really get a good idea. So we have 3 circles. The inner is the inner wall. So this is the void, if you will. This is how thick the actual tube is, and this is a little bit of extra space to allow you to put the tube through the plates when we get to it and weld them in, so that you're not a friction fit. You don't need this to be friction fit. You need to be close enough for a weld, but not nuts. You know what I mean? Now we can go ahead and exit that sketch and get an idea of our next sketch, which we can zoom out, turn it around, and that is where we create our plates that go to the frame and the plate that goes to the transmission. So what you can see when we turn that into an actual solid on our extrusions, that's what it'll look like. And again, to get an idea what the space looks like, those are the most important parts. We have our plates and we have our tube mocked up. From there, we can just move things around until we're happy, like making adjustments. We didn't need it so tall, so we dropped it down. Scoot this over a little bit more. Oops. And you can start to see things kind of come to fruition. What we're creating here are the gussets that are going to support the lower bracket from the tube. We can then extrude them, and that's what they'll look like. Now, we don't need that much material, so we can kind of just shave it down a little. Again, you put a drawing, and how you create a drawing, if you want to see that, we'll just scoot this around, and I'll give an example. So you select the face that you want to draw our drawing on, and select the draw thing, which is up over there. This is not sponsored. And you can actually hide the body again up in this corner, put that little eyeball, poke it right in the eyeball, knock it there, it's blind. Can't see what we're doing. And then you just draw our lines. So you can, do all kinds of fun things. You can explore the program. There's plenty of things. This isn't a tutorial on this. This is just to let you guys think, hey, let me get and doing this stuff. So we'll exit out of the drawing because we don't need to actually do any more drawings, and we will get an idea of the next phase of our creation, if you will. So let's open this back up so we can see our constraints, what we could hit. And once we're happy, we can then, so that's right, I trimmed that down. We went back too far. There we go. So that punches the holes in it, right? That creates our little angle of the dangle to remove some of the metal that we don't need. Just, you know, make it look nicer. I didn't end up doing that for my cuts, but it does make it look nicer. And I did leave one thing out so I can show you guys once we get closer to it. Oh, there we go. So my initial drawing for the plate was not long enough. So what I did was I actually used the extrusion tool and I extruded this out till it reached this face here. And that gave us a nice plate. And the last part was to create our drawing for our transmission. Now, in our drawing, it was pretty straightforward. You have a part of the transmission mount sticking through. The other one didn't scan very well, so we don't have that one. But we know where this one is, and we know that they're symmetrical. So we create a slot so that when the transmission mount goes in and then pivots up, it has room. And you can adjust it as you need it. And then what we did was we created a reference line right here, and we used the mirror tool to flip it to there. Oh, and real quick, what we end up doing is once we finish the sketch, we then use our extrusion tool again to then punch the holes out. Now, the really cool part about it is you won't have to sit there and make 3 attempts to get it right. Once you have your scan, you verify a couple of the measurements to make sure that your scan is accurate. That's very important. For example, from frame to frame, it was 33 1/4. I scanned it, it was 33, and I mean, it was like off by maybe a 32nd of an inch. So just take that in consideration. The way I did it was the brackets that mount it to the frame, the actual tube goes through it. So it gives you a little bit of wiggle room. This is pretty accurate. Now, me cutting it up with grinders and stuff like that later, that's not so accurate. But, you know, I work with what we got. Now, if you guys end up wanting me to make these for you guys, then it's different. We'll send that out to a plasma table to have it cut. One, it will be a lot quicker than me doing it, and it will look a lot nicer. I'm really just prototyping it, and I'm the guinea pig. So that's what it is. It's pretty simple. As you can see, with almost no time at all, you could have a finished product like that. Can other things be very complicated? Absolutely. You may have to put some bends in it. If you want to learn how to use CAD, you know, it's pretty easy, fairly easy. There's a lot of YouTube tutorials on it. This isn't one of them. This is me just saying you can design your own stuff in your own house and make sure that it's going to work. You can run this through simulations to make sure that it's not going to fail. Wonderful software. This is Fusion 360. The Pro is expensive. This is not a sponsor. I put it up there just to make sure this is not sponsored, guys. I totally recommend getting it. Now, the next phase is to use the butchery outside to mock up a prototype and fit it to the truck. Have you ever seen those videos of those peoples in the far-flung parts of our world that are putting things together with, you know, random crap, and they're using their toes to hold things? Yeah, I don't think I could throw stones, but I do have closed shoes on at least. I just want to interrupt real quick. This is future Brian with a much better haircut. We were able to, you know, make sure everything fit, and once we were able to make everything fit, I actually had pieces cut from Send Cut Send. So if you order a kit, it's not me sitting here in my driveway with a, you know, cut a wheel cutting 1/4 inch plate. That was a nightmare. Yeah. Anyways, so if you're interested in doing an Allison swap inside your square body, head over to LunarOutlaw.com. You can pick up this kit right here. If you're on a budget, save yourself half the cost by just picking up the kit and welding it yourself, painting it and everything like that. But if you want to spend the full amount of money, we can do it for you and get it all welded up. Either way, it's a little glorious inside your square body. Now back to old Brian, younger Brian, technically younger Brian, not as good haircut, also struggling with, you know, cut off wheels and stuff. I don't envy him, but I do look better. You know, age like fine wine. Anyways, back to him. The most important part is safety squints. Now that we went through the process of scanning the environment, creating it in CAD, and using advanced manufacturing processes, yeah, quality manufacturing processes to develop this right here, you can see that it's pretty stout, as it should be, as it's made out of 1¼ roll cage material with cold rolled 1/4 inch thick steel plate. Now, this is meant to be more of a prototype. I will use it on this. If you guys are interested, you can actually go to the website. We'll be able to order this right through there. About 2-week turnaround. I'll actually have to send it out to have the plates machined out of a plasma table. And we'll weld it together for you and ship it out. That being said, this guy right here is pretty stout. I don't know if I already told you, I just like doing that. It's just, fries are done. It's awesome. Anywho, we got to get this thing clean with some isopropyl alcohol, or you could use something like acetone. Just get the oil and crap off of it. You've been welding on it, you've been touching it. You know, all that stuff is not good for, you know, paint adhering. Then we're going to knock out some coats of self-etching primer. Light coats, doesn't have to be crazy, but we want to make sure whatever layer we put on next is going to be there for the rest of its life. Not that I'm worried about this thing rusting away into nothing. That would be impressive. Actually, that would be a miracle. This thing is like hardcore. Yeah, this is strong enough to do what we're doing. Anywho, let's get this done. Now, we did just have a little bit of a deluge come through here. Not too bad, and we may get another one in a little bit. So we're going to try to get this together in the little window we have. Now, before I forget, I did end up having to chop the floor to fit the Allison transmission. It wasn't a lot. In theory, you probably could have done it, or I could have done it with a 13-pound sledgehammer and just, you know, closed my eyes and said it was fine. But we're doing this the right way. Mostly the right way. So we clearanced the floor, and you can see it here. And we'll show you how to make your own patch panels with a 3D printer in the coming days. It's going to be really awesome. So let's go ahead, get this thing fitted in there, and show you how it installs. Now we have to do the obligatory, that's not going anywhere. And it looks pretty good, I gotta say. I mean, for almost getting rained on and kind of being a little bit tacky, it went in pretty nicely. If you want to continue following this project, we have a lot to do on it. We still have to do fuel lines, brake lines, radiator core support. All that stuff needs to be put together. And we need to wire it, program it. And we'll go through how you can do that. It's very similar to what you'd need to do with an LS at this point. So make sure you hit that subscribe button. Hit the thumbs up. Lets the algorithm, I think it lets, I don't know what the algorithm does these days. But, you know, it just shows me that you enjoyed the content. And head over to LunarOutlaw.com again. You know, it helps us out. Keep your shiny side up. God bless. Oh, old man noises.